Good morning to all. So in today's session, I'm going to discuss about a topic on recursion. In the previous discussions, we have seen the concept of functions. A function is nothing but a set of or a group of statements that can perform a particular task. While discussing the concept of functions, we told that we have two different types of functions, that is the user defined functions and the predefined functions. When coming to the concept of user defined functions, you means the programmer can write any number of statements and he can give a solution to a problem. That is what a user defined function is. But at that point we have discussed one very important point, that the functions are basically inactive. So in order to activate these functions, you have to invoke those functions. How do you invoke those functions? Just by making a function call. So function call is a mechanism where you are going to call another function in order to invoke it and in order to get some task completed. This is what we have seen. So function call is a term that we have learned at that particular discussions. For example, if my program consists of three functions, f1, f2 and f3, there is no limitation on the number of functions that you are going to define in a program. I told that you can have any number of functions, right? But for my example purpose, let me take that my program consists of three functions, f1, f2 and f3. And we also know the concept that a function can call any other function any number of times. So function f1 can call f2 any number of times. Similarly, it can call f3 any number of times. And if you consider function f2, this f2 can also call the function f1 any number of times and it can call f3 any number of times. Similarly, f3 can call f1 any number of times and it can call f2 any number of times. This concept we are very much clear, and we have seen a lot of example programs related to these function calls. That means one function calling any other function any number of times. But we didn't hear the term a function calling itself. The point you have to understand here is, the question is whether a function can call itself or not. That means f1, can it call itself? So if I want to, for example, if f1 wants to call f2, I just call it with the function name. Similarly, if f1 wants to call f3, it can call it with the name like this. So this is the function call statements. We know everything. So my question here is whether a function call itself or not. That means f1, can it call itself like this or not? Similarly, f2, can it call like this or not? And f3, can the function f3 call itself or not? These are the questions we have. The answer to this particular question, that whether a function can call itself or not, is perfectly yes. Yes, a function can call itself. So the procedure or the methodology where a function calls itself is called as recursion. Here is a new term we are introducing at this particular point. Please concentrate. Recursion is a very, very important topic. So you will write lot of programs related to this particular concept which is called as recursion. So if somebody asks you what do you mean by recursion, it is a process where a function calls itself. So this particular recursion concept is familiar from the C programming itself. So in C programming we have a methodology where a function calls itself, that is called as recursion. Similarly, we have another terminology called as recursive function. Recursive function. So recursive function is nothing but a function or a procedure which implements the recursion procedure is called as recursive function. Probably in the laboratory sessions you might have seen the program of Fibonacci series, where you are calling the same function, Fibonacci function, 2 times. Fibonacci of n-1 plus Fibonacci of n-2. In order to calculate the new term is equal to of n-1 plus Fibonacci of n-2. So this is a function Fibonacci calling itself. Therefore the Fibonacci function is called as the recursive function. Why it is called as recursive function means it is going to implement the process of recursion. So any function in C program you take, if it is going to implement the recursion methodology, those particular functions we call them as recursive functions. So up to this point we have seen what a recursion is. A recursion is a process or a methodology where a function calls itself, and we have seen the recursive function where a function which implements the process of recursion is termed as the recursive function. After this, let us go into the discussion of what are the components of recursion. What are the components of recursion? What does a recursion consist of? So one important point regarding these components of recursion is it consists of 2 different cases. One is called as the base case. The second one is called as recursive case. Any recursive function you take, it should have these 2 components. For example, Fibonacci series you take. This is a recursive function. Why? Because it is calling itself. Therefore, this is a recursive function, and this function should have these 2 cases, the base case and the recursive case. Similarly, there is another very familiar example for the recursion, that is factorial. In order to find the factorial of a given number, you are going to implement this particular program using recursion concept. So the 2 very good examples that we can give for the recursion concept is the factorial and the Fibonacci. There are so many programs where we can implement using the recursion concept, but most familiar programs where you can write in a simple way is the factorial program and also the Fibonacci program also. Any recursive program or any recursive function you take, they should have these 2 different cases. One is the base case and second one is the recursive case. What is this base case and what is this recursive case? Let us start with the recursive case. So the recursive case is a set of statements, or it is a group of statements which calls or which iterates for some n number of times, which repeats itself for n number of times. You can observe here that I am using the term repeats. So this recursion is having some relation with the concept of loops or iterative statements. We have seen the concept of iterations or the looping constructs that are available in C in the previous discussions, right? The C programming language supports three types of looping constructs, that is for, second one is while, and the third one is do while. We know that these three constructs are used to repeat a set of statements for n number of times, or to have some iterations, repetitions. The same is the case with the recursion. When a function calls itself, that itself, the concept itself is leading to the concept of repetitions. So when you implement recursion, you are indirectly repeating some set of statements, and the set of statements that are repeated are kept under this recursive case. What about the base case? If you consider the concept of loops like for loop, while loop and do while loop, you can observe that these particular loops has to be given a very good condition, which is called as the termination condition. So you should specify a termination condition so that the iterations will stop or the repetitions will stop. In the similar manner, as recursion is also repeating some set of statements, there should be some condition by which the recursion will stop. So those conditions by which the recursions will stop should be specified under this base case. So that is the concept of this recursive case and the base case. Recursive cases tells or it constitutes the group of statements, which can repeat for some number of times, whereas the base case is the situation or the condition where the programmer has to mention or where the programmer has to specify in order to stop the recursion process. So this can also be called as termination case. Why? Because you tell when to terminate this recursion, and this is also called as repetition case. Why? Because it consists of group of statements to repeat the same things to happen. So this is the base for any recursive function you take. These are the two components. If you forget to specify the base case, then it will enter into an infinity loop. Perhaps you should not tell that you should not make use of the term infinity loop. We call the situation as, in order to understand, I am just mentioning it as infinity loop. That means it will enter into some infinite number of repetitions. So if a recursive function enters into a infinite number of repetitions, that situation we call it as memory segmentation. That means the available memory for that particular program has been exhausted. It has been completely used, and there is no memory to withhold the variables or the values that are being calculated in the recursive function. So that particular situation where the complete memory has been utilized, here we will make use of a concept or the memory called as stack. I will also discuss about this stack area, and So the recursion makes use of a memory area which we call them as stack. So at one particular situation, if you did not specify the base case properly, or if you don't specify the termination case properly, what happens here is the entire memory will get occupied by the recursion. Therefore the memory is not available to hold the values. That particular situation is called as the memory segmentation concept. Segmentation fault, we call it as segmentation fault, clearly. So this is all about the components of recursion, and here you have come across a new concept that we have some relationship between the loops and the recursion. Therefore there is a need to discuss the differences between the loops and the recursion. Whatever it may be, we can call it as differences or the similarities, right? We know that the loops are used for the purpose of repeating a set of statements. The purpose of recursion is also same. It is also used to repeat a set of statements. This is the similarity we have. In loops, you can make use of the looping constructs such as for, while and do while. Whereas here you will make use of the if else constructs, which are called as conditional statements, or condition, they depend upon the condition, right? And loops have the termination condition. Similarly, recursive function should also have the termination condition, which we are naming it as the base case. And very important thing, again, as an initial programmer, as a basic programmer, you will have a doubt that when to use the loops and when to use the recursion. So very important concept. Even though both of them serve the same purpose of repeating a set of statements, whenever the performance has to be considered as the most important criteria, then never ever choose the concept of recursion. You always try to implement the programs using the loops. So when performance is a criteria, don't ever go for the concept of recursion. We'll discuss why it is very important to consider the performance, and why it is important to not to consider the recursion when the performance is important. So always try to write the programs using loops when your criteria is the performance. Why? Because recursion involves a lot of overhead. Overhead means it is a disadvantage. Perhaps this is the overhead that is involved in any function call. I will tell you all these things with a programming example. So any function call involves some overhead. So if a function calls itself, that means it is involving the concept of function call. Therefore the same overhead which is involved in the function call is also present inside this recursion concept. So because of this overhead, this one, I'll tell you what is this overhead. Because of this disadvantage of the overhead that is involved in the function call, we are not going to prefer the recursion. For this purpose, this is very important, right? So that question is clear, right? When to prefer loops and when to prefer recursion. So if performance is not a criteria, then you can write your program either using loops or recursion, nothing wrong in it. But when performance is a very important criteria and you should take care of the performance, then better write your programs using loops instead of writing them using a recursion concept. This is purely because of the overhead that is involved in the function calls, and since the recursion is also a function call, the overhead involved in the function call will come into existence for this recursion also. So avoid recursion when performance is criteria. But there are so many situations where we can write a program using loops, this one, and you can convert it into recursion. The vice versa is also possible. The vice versa. So when you write a program using recursion, you can convert it into loops. Nothing wrong in it. So the concept here is, the point you have to understand here is, programs written using loops can be converted into the recursion concept. Similarly, programs written in recursion can be converted into loops. So with this basic idea on what a recursion is, what a recursive function is, what are the components of a recursion, and the differences between the loops and the recursion, we'll quickly go through the slides and we'll see whether any new points will get here or not, right? So here is the definition for the recursion. So the recursion is the process of function calling itself repeatedly. I told you already. And this is a historical background, how we got this recursion. So recursion is a programming technique that comes from the mathematical background, which is called as the recurrence relation. You might have seen the concept of recurrence relations, where the big problem is divided into sub-problems, and those smaller problems will be in smaller size, but they are of the same structure, they are of the same behavior, they are of the same nature. So smaller problems, everything will be in the same structure, and you try to find the solutions for those smaller problems, and then try to combine the solutions of the smaller problems to get the solution for the larger problem. It is something similar to that of divide and conquer technique, which will come across in the data structures concept or the algorithms concept, design and analysis of algorithm. That's a different case, but you just have an idea of where from this recursion has been introduced. The recursion has been introduced from the mathematical background, or from the mathematical concept of recurrence relation, where you are dividing a given problem into smaller pieces of equal, not equal sizes. It's not mandated to have equal sizes, but they should be of same nature, and then you find the solution of the smaller pieces and combine it to get the solution for the larger piece. So the division stops when the problem cannot be further divided. So up to what part you have to divide? I know that I have a large piece here. I started dividing it into some n number of pieces. How many pieces you have to divide means you have to divide the given problem into smaller pieces unless the problem cannot be further divided. So by writing the programs, you will come to know when to stop and when to further divide the program. That's a different case, nothing to worry about it, right? The important point you should understand here is the definition part, this one, and similarly the concept from which the recursion has been introduced. That's it, nothing more than that. And similarly, we have discussed this recursive function. A function calls itself over and over again. That function is known as a recursive function. In simple terms, you can also say that a function which incorporates the recursion concept is termed as the recursive function. Everything we have seen. And coming to some introductory part related to the recursion. Recursion is a useful programming tool and is encountered frequently in the data structures and algorithms. So you have the data structures concept in the next semester, where you will come across a lot of programs or lot of concepts which can be implemented using this recursion concept. And all method calls, method means nothing but, here we are calling it as the function. In C program we are calling it as function. In some other program they may call them as procedures also. So methods, procedures, functions, routines, ROUTINE, are different terminologies that are used for the functions. So remember that everything is nothing but a set of statements that are grouped together to perform a particular task. So the function calls, recursive or otherwise, any function call you take, whether it is a recursive function call or a function calling another function, like we have seen in the previous example, f1 calling f2 or f1 calling f3. Any function call you take, they have certain overhead operations that is associated with them. So any function call will have some disadvantage, that is in terms of overhead that is involved in the function call. I will tell you what is this overhead, right? At this point only we will discuss. So recursive methods are often more expensive than their iterative equivalents. So remember that the recursion and iteration, I have been telling you from the starting point of the discussion, recursion and iteration both have some relation. Both are same. Both are used to implement the repetition concept only. Even loops are used to iterate the things, and the recursion is also used to iterate the things. But remember that recursive methodology is always expensive than their counterparts, which are nothing but iterations or loops. Because I told, right, the function call, the recursion involves the function call of itself. Whenever you have a function call, you have the overhead of function call, right? Now let us see what is the overhead that is involved in this function calls. Let me take the example that I have two functions, and after some statements I am calling the function f2 like this, and f2, I have some set of statements in f2, right? Listen carefully. So initially f1 is executed. Let us assume that f1 got this execution. So after these 5 statements are executed, let us say that there are two values x and y that are calculated up to this particular point, and after these 5 statements there we have a function called f2. So during function call we have discussed that the control will be jumping from the control function call statement to the function definition, right? This is very much clear. And after executing the function body of f2, the control will again return back to the calling function. This we all know everything, right? So let us go deep into this discussion. So f1 has started its execution, and after 5 statements, let us assume that there are two variables x and y which have some values calculated up to that particular point, and in the 6th statement I have a function called f2. We know that at function call the control will jump from the calling function to the called function definition. Okay, up to here we are very much clear. So this is the first overhead involved. before jumping the control from the calling function to the called function definition, whatever values that are present are calculated up to that particular point, up to that function call, that is x and y. All these values has to be stored in a memory location, has to be stored somewhere. That somewhere is nothing but they have to be stored in some memory location. So the memory which is used to store during function, to store the values during function calls, is called as stack. So stack is nothing but a memory. We are just renaming it, right? Instead of, we have two types of memories, primary memory and secondary memory. Like that, we are giving another name to a particular location of the primary memory as stack. So we have this much of primary memory, and out of this I call from here to here, I designate it as stack. I means the OS, the operating system will designate. So the operating system will designate that out of this entire primary memory that is available, from this memory address to this memory address, it is designating it as a stack area. It is called as stack area. So this stack area, why it is designating it separately means the stack area will not be utilized for any other purpose. This is reserved. We can say that it is a reserved memory. So this reserved memory can be utilized only during the function calls. So when a function call has been taken place, the control will jump from this place to this place, or the calling function to the called function definition. But before jumping the control from calling function to the called function definition, all the values that are calculated up to that particular point has to be stored in a memory location which is called as stack, right? So from here it will take all these values and it will be stored in stack. So this is the first step that happens here. What is the step 1? I am just writing it here. Step 1 is store values in stack. After storing these values onto the stack, the control will be jumped from the calling function to the called function. So this becomes the second step. So let me write like this. Step 2 is control jumps from calling function to called function definition. So this is step 2. After that, it will execute the body of the function. So F2 will be executed. So what is step 3 here? Which is nothing but execute the function. This is nothing but called function. And after executing the called function definition, the control will jump back from the called function to the calling function. So step 4 will be return control from called function to calling function. Once the control has been returned back from the called function to the calling function, now what it has to do? It has to retrieve back all the values of this function. Where the values of this x and y has been stored, the values of x and y that belongs to function f1 are being stored in the stack. Therefore, next step is it has to retrieve back all the values from the stack. So this is step 5. So what is step 5? I am writing here. Step 5 is retrieve all values from stack. So after that it will execute the remaining part of the calling function and it will finish its execution. So if you observe that what happens during a function call means all these 5 steps will happen. Very, very important. So initially it will store the values in the stack. What values? These values are nothing but calling function values. So whatever calling function is there, those values that are calculated up to the function call will be stored in the stack. Then control will jump from the calling function to the call function procedure, execute the call function, next return the control from the call function to the calling function, and finally retrieve back all the values from the stack. So these 5 steps are involved in any function call. You take any function call, all these 5 steps should happen. So all these 5 steps constitute the overhead. Overhead of function call. So these 5 steps are constituting the overhead that is involved in any function call. So if a function f1 calls f2 one time, all these 5 steps will happen. If it calls another function f3, all these 5 steps will happen, but with respect to f3. Again assume that f1 calls f2 now. So again all these 5 steps will happen. So any number of times you call a particular function, all these 5 steps will happen. We combinedly call these 5 steps as a single entity, which is called as the overhead of the function call. So this is what happens in the function call, and that we are calling it as the overhead involved in the function call. That is the reason why recursive methods are more expensive when compared to that of the iterative equivalence. Right. Now let us discuss about the recursion versus iteration. As we have discussed that both of them implement the repetition. Okay. Both of them are used to repeat a set of statements. And remember that iterations make use of the repetition constructs. What are the repetition constructs we have? For, while, and do while. Whereas recursion makes use of selection constructs. What are the selection constructs we have? If else, etc. So recursion always makes use of selection constructs like if else, and the iteration makes use of the repetition constructs like for, while, and do while. And I told this point also, we have discussed it. Both of them involve the termination test. Without termination test, you cannot write the repetition iteration programs or the recursive programs. If you don't give the termination test, both of them will end into some problems. So if it is a iteration, it will end up in infinity loop, and if it is recursion, it will end up in segmentation fault problem, right? So the termination condition is specified in the loops with the termination condition, whereas in the recursion the termination test is given in terms of the base case. So iteration has loop conditions. And this is very important. I told, right, both of them have the potential for endless looping. So both of them may end into the endless looping if you don't specify the termination test properly. In the case of iteration, we call the condition as infinity loop, whereas the problem that arises if you don't give the termination test properly in the recursion is segmentation fault. And This one also we have discussed. Any problem that can be solved recursively can be solved iteratively and vice versa. So any program can be converted from the recursive statements to the iterations. Similarly, the iterations can be converted into recursions. And last one, programmers very rarely choose the recursion when they cannot see the iterative solution. So if you don't find any iterative solutions, then only you go for the concept of recursion. And final important point, as I told that, never choose the recursion when performance is an issue. This is the reason is why we are telling you that when performance is an issue, you should not go for the recursion concept. Means recursion is nothing but function calling itself. It involves the concept of function calls. Whenever you have the concept of function call, it has the overhead that is involved during the function calls. So whatever 5 steps we have discussed in the previous slide, storing the values into the stack, jumping the control from the calling function to the called function, executing the called function, returning back the control from the called function to the calling function, retrieving all the values from the stack. These are all the 5 steps that are combined together and are termed as the overhead of the function call. Since this overhead is involved in the recursion, never ever choose the recursion if performance is a criteria. So once we have an idea of this recursion and iteration, we will see the components of the recursive function. This also we have discussed. Every recursive function you take, it has 2 major parts, or we can also consider it as 2 major cases. One is the base case and the second one is the recursive case. So as I told that the base case is a case for which the function is evaluated without recursion. No recursion takes place here, no repetition takes place here, and this is used to stop the recursion. So it does not make any subsequent recursive call. That is the reason why we call it as the termination test. This particular case will tell you when to stop the recursion, termination. And similarly, recursive cases, this is the base of any recursive function, central core part of the recursive function. Here what happens is, divide the problem into one or more simpler or smaller parts, call the function recursively on each part, and then combine the solutions of the parts into a solution for the problem, right? So this is what happens in the recursive case. So it tells how many times you want to iterate or how many times you want to repeat the set of statements. So very important components, base case and recursive case. Base case specifies the termination test and the recursive case specifies the number of times the repetition should happen. And this is a simple example of comparison between the recursion and iteration. As I told that the majority of the iterative operations can be coded as the recursive routines. You can convert a iterative solution into a recursive solution, and you can convert the recursive solution into a iterative solution. Nothing wrong in it, right? But choice is dependent upon the programmer's logic. Whether you should go for the recursion or not, it is purely dependent on the programmer's choice. So if you observe the first program, this one and this one, both of them we are making use of the concept of factorial program. We know how to calculate the factorial program. So if I want to calculate 5 factorial, it is equivalent to 5 into 4 factorial. Then we have 5 into this 4 factorial is equal to 4 into 3 factorial. And then we have 5 into 4 into 3 multiplied with 2 factorial. 5 into 4 into 3 into 2 multiplied with 1 factorial. and then we have 5 into 4 into 3 into multiplied 2 with 1 into 0 factorial. We know that the 0 factorial is equal to 1. Therefore, this is equal to 5 multiplied 4 multiplied with 3 multiplied with 2 multiplied with 1. So this is equal to 120. So this is the logic behind finding the factorial of a given number. If you observe carefully, you can see here that if I consider n is equal to 5, so n factorial, that is equal to 5 factorial, I can write it as 5 into 4 factorial, that is nothing but n into n minus 1 factorial. This is very good. So n factorial, if I rewrite the program, n factorial is equal to n into, that is n multiplied with n minus, n factorial is equal to n multiplied with n minus 1 factorial. So this is the logic behind the factorial of a given number. So let us implement this using the recursion first. So int factorial int n, this int is the return type of the function, the name of the function is factorial, and it is accepting only one parameter, which is nothing but an integer value n. Now by taking, let me take an example, n is equal to 4. If n is equal to 4, it will enter into the body of the function. If n less than 1, that is 4 less than 1, the condition is false. Therefore, it will not execute this statement. Why? Because this statement return 1 is related to this condition. 4 less than 1 is false, therefore it will execute the else part. Therefore, it is going to return n multiplied with factorial of n minus 1, the same program what we have taken, logic. So it is going to return 5 multiplied with factorial of 4. You can see here that the name of the function is factorial, and here we are calling the same function in the factorial. So a function factorial is calling the same function factorial itself. It is calling itself. This concept is called as recursion. And the factorial function in this particular scenario, we call it as recursive function. So what happens here is 5 multiplied with factorial of 4. Here you can see that it is again calling a function factorial of 4. And therefore, it will call the same function. Initially I have taken 5, right? Now I call the function with 4. 4 less than 1, condition false, therefore it will return this value. Therefore, 4 multiplied with factorial of 3. Again, this is another recursive call. Now it will call the factorial function again. Therefore, it will call factorial of 3, and 3 less than 1 is false. Therefore, it will execute this statement. Therefore, 3 into fact. I am just shortcutting this as from factorial to fact, right? Factorial of 2. Therefore, this is again a function call. It will again call the factorial of 2 function. Okay, 2 less than 1, which is false. Therefore, it will execute this statement. So 2 multiplied with fact of 1. Again, this is again a function call. Therefore, fact of 1 is called. Now you can see 1 less than 1 is again false. Therefore, it will execute this statement. So 1 multiplied with fact of 0. Again, there is a function call. Now it will call the factorial function with 0. You can see here that 0 less than 1 is true. It's a true condition. Therefore, it will execute the return of 1 statement. So it is going, the factorial of 0 is going to return 1 value. To where it is going to return means to the previous function which called it. So factorial 0 is called by which function? Factorial 1. Therefore, 1 is returned to this place. Right. Now what happens here? Instead of factorial of 0, we will have 1. So 1 multiplied with 1 is returned here. This is a return statement. 1 multiplied with 1 means again the value is 1. Therefore, 1 is returned to the function which called it. So factorial 1 is called by factorial 2 at this point. Therefore, the 1 value is returned to this place. Now 2 into 1, 2 multiplied by 1 is calculated, that is 2. The result is 2. This 2 value has to be returned to the function which called itself, which called it. So factorial 2 is called by factorial 3. Therefore, the value that is calculated 2 will be returned from here to here, this one. Now 3 multiplied with 2, it will be having a value of 6, and this 6 will be returned to the function which called factorial of 3. So the factorial of 3 function is called by the factorial of 4. So the 6 value which is calculated here will be returned to factorial of 4 at this point. So it becomes 4 into 6. So 4 multiplied by 6 is equal to 24, and this 24 value is returned to the function which called this factorial of 4. So this factorial of 4 is called by factorial of 5 function initially. So this 24 will be returned to the factorial of 5 function. So 5 multiplied with 24, that is 120. This value is calculated. 5 multiplied with 24, 120 is calculated, and this final value is returned to the function which called the factorial. Who has called this factorial function with n value 5? It is nothing but the main function. So the main function will have this value of 120, where you can print it and you can do it on your it depends on the programmer's logic. So this is how the function call takes place in the recursion. See here how many times the function is being called. Here this is one function call with n is equal to 5, okay, and the second function call I have called it with I means the program, the function itself has called with n is equal to 4, okay, second time, and the third function call is with n is equal to 3, this one, and the fourth function call is with n is equal to 2, fifth function call is with n is equal to 1, and the sixth function call is with n is equal to 0, this one. Previously, whenever I have discussed that whenever we have the function call, there is a overhead that is involved in every function call, and that overhead involves 5 steps. We have seen in the previous discussions, right? So when a function factorial is called with n is equal to 5, here we have an overhead of 5 steps. Similarly, when n is equal to 4 is called, it has 5 more steps. N is equal to 3, another 5 more steps. N is equal to 2, another 5 more. Like that, 6 times it has called. Therefore, 6 overheads are involved. That means 6 into 5, 30 additional steps are involved. in terms of this overhead, which is not suggestible. So this overhead is not at all required for our program, right? So it makes the program to run slower. Whenever you make use of the concept of recursion, it makes the program to run slower because of all this overhead that is involved. You should observe what is happening in this recursive function call. So main calls factorial function with n is equal to 5. Then the same function calls factorial function with n is equal to 4. This is another function call. So this one, like that. It goes until n is equal to 0. Now you can see here, if n less than 1, here the condition is terminated or the recursion has been stopped. Therefore, I told that there exists two different cases in any recursive function. The first one is the base case, which tells where to terminate. The second one is the recursive case, which iterates. So if n is equal to if n less than 1, this is the base case. Why? Because it is telling the program when to stop the recursion. And return of n multiplied with factorial of n minus 1, this is the recursive case. So base case is there, recursive case is there. Without recursive case, you cannot make more number of recursive calls. Without base case, you cannot terminate. Therefore, both of them are mandatory in case of recursions. Remember, when you write any recursive function, you have to specify the base case and you have to specify the recursive case. Both of them are very, very important. And if you look at the same version of finding the factorial of a given number using loops, see here, very simple. If n is equal to 5, I take the result is equal to 1 and I am repeating the loop for up to this condition m greater than 0. See here, I am decrementing here. It's not mandatory that updation part is always incremented. It can be the decremental part also. And remember that it may not be decremental, means minus 1, minus 1, minus 1. It may not be all the case. You can decrement it to 2 steps like minus 2. You can decrement it with 3 steps, that is minus 3. This is the programmer's choice, programmer's logic, right? So I am repeating the loop until this condition m greater than 0. That means until unless m becomes 1, it will execute, right? I am just making it as result multiplication star is equal to m. This is a shorthand operator we have seen in the earlier classes, right? So this is equivalent to result is equal to result star m. Initially my result is stored as 1, and what is my value here? Initially m is equal to n, therefore 1 star 5. Result is stored here. So initially, let me take this one, result. Initially I have 1, then I have 5. Again it will go and decrement the value of m, which is becomes 4. 4 greater than 0, condition true. Therefore result is equal to result star m. I already have 5. So 5 multiplied with 4, 20 is stored here. Now m becomes 3. 3 greater than 0, condition true. Now this result is equal to result star m is executed. So 20 star 3, 60 is stored here. Now again m is decremented, m becomes 2. 2 greater than 0, condition true. Therefore result is equal to 60 star 2, it becomes 120. Now m is decremented. M becomes 1. 1 greater than 0, condition true. Therefore result is equal to 120 star 1, 1. M is decremented, m becomes 0. 0 greater than 0, condition false. Therefore it will come out and it is going to return the result. What is the value of result? Is nothing but 120. So both of the things you can observe, you can see how simple the iteration solution is from here to here. Both of them are used to find the factorial of a given number, but both of them are giving the same result also, but what happened here, the calculation of factorial of a given number using a simple for loop is very simple, whereas by using recursion all this overhead is involved. So main calling factorial 5, factorial 5 calling factorial 4, factorial 4 calling factorial 3, and so on like that, and again returning back the values to the function which called them is a big overhead that is involved in every function call. That is the reason why we are stressing on a single point, that never ever choose recursion when performance is an issue. When you choose recursion, you are involving yourself in function call. When you are involving yourself in function call, you have lot of overhead involved in it. So this overhead will lead to the slower execution of the program. Right? So very important points you should observe during the recursion is, don't ever make a mistake in writing the base case. Base case is the case which tells the termination point of the recursive call. So write properly, you have to properly write the base case, and whenever you don't want to go for the performance issue, just go for the concept of iterations. Try to implement the functions using iterations. Now let us quickly go through, we have only 2 slides here, let us quickly go through the concepts of the types of recursion. So there are so many types of recursions we have. I told that a function calling itself, for example a function f is there, if a function calls itself, this type of methodology or the process is called as recursion. Right? But there exists a problem here. For example, there exists a question here. For example, in a function I have 2 functions f and g. Let me take a scenario where f calls g and g calls f. Is this a recursion or not? I told that according to the definition of recursion, a function should call itself. That type of process is called as recursion. But here function f is not calling itself. It is calling g, and the g function is calling, it is in turn calling the function f. Does this come under recursion or not? This is the question we have. But the answer is, it definitely comes under the concept of recursion. Yes, it is a recursion concept. But this type of recursion, we call it as indirect recursion. So f is calling itself indirectly via g. So this is also a recursion, but it is a case of indirect recursion. But if a function f calls itself, this is called as a direct recursion. This is the 2 important points you have to observe here. So a function may call itself directly, that is called as direct recursion. A function may call itself but indirectly through another function g. That recursion is called as indirect recursion. So we have different types of recursion here: linear recursion, tile recursion, binary recursion, multiple recursion, and nested recursion. So the concept is very simple. We know what a recursion is, and we know what is the term linearity means. So the linear means if a linear function calls exactly once, this one. If a function calls exactly once to itself, that particular function, we call it as the linear recursion method. So only once. For example, in the previous example, we have taken the factorial of a given number. factorial of a given number is n into factorial of n minus 1. So it is calling the function factorial, that means it is calling itself exactly once. Therefore, the factorial of a given number is an example for the linear recursion. And this is the most commonly used thing. And coming to the tail recursion, the name itself, we know the concept of recursion. We know the tail. Tail means at the end. So this is another form of linear recursion where we are going to call a function, or a function calls itself exactly once. But what happens here is the recursion is done as the last statement. So you are giving the recursion as the last statement. That means you don't have any statements after that recursion function call. In the previous example also we have seen that factorial of a given number, as the last statement we are giving it as return of n multiplied with factorial of n minus 1 as the last statement. Therefore this is also an example of tail recursion. Tail means at the end. So when you specify the recursive function call at the end, that particular recursion, we call it as the tail recursion. So this tail recursion has some efficiency when compared to that of the linear recursion. So when you find the GCD of a given number using recursion, you make use of the tail recursion. Similarly, when you are reversing the array elements, you will make use of the concept of tail recursion. And the third category of the recursion is the binary recursion. Here you can see that recursion binary, bi means 2. So you might have observed what this recursion is. So a binary recursion is a function that makes 2 recursive calls to itself when invoked, is called as the binary recursion. So it makes 2 recursive calls to itself. Such type of recursion concept we call it as binary recursion. For example, Fibonacci series, very familiar example. So in order to find the new term, we will call the Fibonacci function 2 times in the same statement with n minus 1 and n minus 2 values. So since you are calling it 2 times, this is an example of binary recursions. Similarly, finding height of a binary tree, operations of tree traversals, all these things come under the category of binary recursions. So these are all the terms related to data structures. Operations for trees, finding height, all these things you will come across the data structures concept. And next category, fourth category. This is first, second one, third and fourth. Multiple recursion. The name itself is saying that you are going to implement the recursion multiple times. So when you are going to, when your function is going to call itself for more than 2 times, such type of recursion comes under the category of multiple recursion. So recursive calls possibly more than 2 is called as the multiple recursion. And the last category is nested recursion. We know the term recursion and we know the term nesting means. Nesting means one thing inside another thing, right? So it is very difficult, which cannot be programmed that much easily, but still the concept exists. That means one recursion function call within another recursive function call. Very, very tough one, right? So this example for this nested recursion is Ackermann function, which is a mathematical concept to find the Ackermann function value. For this, that means to calculate the Ackermann function, we can make use of the recursion, and that too we can make use of the nested recursion concept. So very important point. All the 4 above recursions like the linear recursion, tail recursion, binary recursion and multiple recursion, they can be converted into their equivalent iterations. I told, right, any recursive function can be converted into an iterative equivalent, and iterative equivalent can be converted into the recursive equivalent. But that is not applicable to this nested recursion. You cannot convert the nested recursion program into the iterations. This is the most toughest thing which you can implement. Right. So these are the various types of recursions: linear, tile, binary, multiple, and nested recursions. And this is our last topic of discussion for today's session, that is the advantages and disadvantages of recursion. Coming to the advantages, recursion is more elegant. It is very simple to look into the things, right? But it's very difficult to implement. Recursion is always difficult to implement. It is very difficult to program. It is very difficult to debug the things. Everything is difficult, but the program looks very simple when compared to that of the iterative equivalent. Very simple programs you can write. And similarly, it requires very few variables which make program clean. So if you consider the concept of iterations, you need to maintain a lot of variables like counter variables. So for one for loop, you will maintain one counter variable like I. For another for loop, you have to maintain another counter variable like j. For another loop, you need to maintain another counter variable. So the number of variables that we make use in the looping constructs is more when compared to that of these recursions. So recursions make use of very few variables, so the program looks very small and clean. And actually the recursion can be used to replace the complex nesting code. So if you have nested loops, you can easily write a logic for that particular program in terms of recursion. And coming to the disadvantage, it is very hard to think the logic of a recursive function. This we have discussed, and it is very difficult to debug the code containing recursion. Why it is very difficult to debug means because it involves the concept of function calls. Whenever you have function call, overhead is involved. Where at what function call the problem has arisen, it is very difficult for the programmer to identify the things. So very difficult to debug the code containing recursion. So with this discussion of advantages and disadvantages of recursion, we will put an end to our discussion of recursion. Let us have a quick recap of what we have discussed in today's session. We have started our discussion with what a function is. We have seen that how you can invoke a function using the function call concept, and what is the definition of the recursion, what is the definition of a recursive function, and then we have seen some history from where we have got this recursion concept, which is nothing but the recurrence relation from the mathematical background. And then we have seen the relationship between the iteration and the recursion. When to use iteration, when to use recursion. Remember two important points: never ever choose recursion when performance is an issue. Later, we have seen an example of factorial program. We have compared it how efficiently we can write we can trace the program using iterations rather than the recursion. Recursion always involves the overhead of function call. Therefore, we should be very careful in writing the recursive programs, in choosing the recursive programs. If there is a chance to write the same program using loops, it is better to go for the loops concept. Otherwise, you go for the recursion concept. And then we have seen the components of the recursion, where we have two components. One is the base case and another one is the recursive case. And after that, we have seen the various types of recursions like linear recursion, tile recursion, binary recursion, multiple recursion, and the nested recursions. And we have ended our discussion by discussing the topics of the advantages and disadvantages of recursion. That's all for today's session. Thank you one and all for joining the session.